Hi there, and welcome to another edition of Learning About Math. Today we're going to be focusing on word problems, and two specific word problems. The first type is going to be on work. So, questions like, if two Jedi take 5 hours to build a Jedi temple, but 5 Sith only take 4 hours, if they work together, how long would it take? These are important questions to understand. Also, would you rather be a Sith Lord or a good Jedi? And of course, other problems that are based on solutions. So mixture problems. So think of being in a science lab and mixing chemicals together. We'll look at those two types, how to solve them, and hopefully you'll be more comfortable answering those kinds of questions. Let's get to it. Okay, so we're going to take a look at work questions. And you're going to see these questions pop up all the time. So when we're talking about work questions, we are talking about when people are doing things either individually or together. And there's an awesome formula. And the formula goes like this. 1 over how long it takes for the first person plus 1 over how long it takes for the second person, and this is equal to 1 over the time it takes together. And that's it. The thing to note is one of those will have an X, because you won't know. A question is going to ask you either how long does it take them together, or how long does it take one person, given this is how long it takes together, etc., etc. So assume that one of these denominators is going to have an X in it. So let's see a question, shall we? And let's make a really good question. More importantly, we need a really good color. It seems like we're going with purple, so let's go with, I guess this is Magneta. And for our topic today, here we go. A Jedi can paint a house in 12 hours. Not bad. A Sith can paint the same house in 9 hours. He probably cheats. How long would it take them to paint the house together? Now, I know what you're thinking. Why would a Sith and a Jedi actually do this together, right? And a couple things as I'm trying to work this out. Whoa, this is getting exciting. Can we assume that you guys remember? Because I want to shrink this, but I don't know how to shrink it. This is great when you get to watch me actually learn how to do this in action. Oh, there we go. That was pretty cool. And it looks it needs to get smaller. And there we go. Now we have our question. Let's get rid of this little floating thing. Okay. So what we're going to do, well, let's use this idea. The Jedi is obviously the first person, and it took him 12 hours. Because he's probably meticulous and he's probably enjoying life. And then the Sith, he's probably, somehow hiring some kind of henchman to do it, and he does it in 9 hours. But then all of a sudden, they have some kind of Star Wars universe detente, and they work together. And I want to know, basically, how long would it take them to do it if they work together? Well, these are one of those times when you have your handy-dandy calculator. I have mine out beside me. I never leave home without it. And I'm just going to add these fractions here. And if I add 1/12 and 1/9, I get the awesome number of 7/36. So 7 over 36 is equal to 1 over x. Now let's go back to our kind of cross-multiplying days. And I know I can go and cross-multiply. And I can cross-multiply the other way. And I'm going to get an equation. Now there are some faster ways to do this for sure. But if you do it that way, the tried and true, you'd have 7x is equal to 36. So x is equal to 36 over 7. And that obviously doesn't seem very nice. But if you had to go and convert that into hours, that would be 5.14 hours. Depending on your teacher, they may want you to convert that 0.14 into minutes and seconds. But you know what? For today, I'm going to leave it just like this. Now, we're going to take a look at solving mixture or solution problems. Oftentimes, these questions will have stuff about mixing chemicals like you're in a science class. But because today is a Monday when I'm recording, and I have just had my cup of coffee, and there's my coffee. Ooh. Yes, it was a mocha coffee, in case you're wondering. Let's add a question that's going to involve coffee. A few things, though. This is going to help you guys out. Is if you ever see one of these mixture problems and they say pure, this means a pure mixture is 100%. And that's going to be important. Now, I'm going to teach you guys something that I did not invent at all, but when I was taught it, it's called the bucket method. And the bucket method is pretty cool. It basically says this: when you are solving a solution or a mixture problem, and it always involves taking some things and mixing it together and getting something else. Well, you always have some buckets. Typically, a question has 2 buckets and it gives you some kind of a mixture. So imagine you had things in these buckets and you mixed it all together. And I want to know, what do you get when you do that? So this first bucket is kind of what you start with. So what do you start with? What do you add? And then finally, what do you end up with? Now for each bucket, you need 2 things. Number 1, you need an amount. And number 2, you need the type. So for a typical solution chemically kind of questions, you have how much, the amount of typically like a 10% solution or a 12% solution. Those ones always seem a little bit intimidating because you have percents and decimals all mixed in together. So we're going to start with a coffee question. And it's going to look like this. How many pounds of coffee worth $1 per pound must be mixed with 15 pounds of coffee worth $1.60 per pound to obtain a blend worth $1.20 per pound? Wow. So we need to go and keep the question there, but let's get a nice blank slate. And where are we going to go with this? Well, the very first thing is we had our buckets, and maybe, do you want to keep the buckets? I hear you saying yes in front of your computer. So, yes, Mr. Douglas, we want to keep our buckets. So let's go and do it. Sure, why not? So the very first bucket is how many pounds of coffee worth $1? So when you see how many pounds, you know we don't know what that is. So when you don't know something in math, you make it an X. But we do know the type, and the type is $1. Now the other one is going to be mixed with 15 pounds of coffee worth $1.60. So how much is there? 15 pounds. And what's it worth? $1.60. So that's a type. This is $1.60 coffee. It's a lot better than the dollar coffee. And I want to eventually obtain a blend that is $1.20. So I want it to be a $1.20 type of coffee. Well, if you just think about it, because we're still missing something here, what goes there? If I blend this amount and this amount, well, how much would that be altogether? It would be X plus 15, just like that. So don't forget, so in that top part, in the very top part, you guys have basically the amount, how much. In the bottom part, you have the type. So now what do? Well, you're basically multiplying these things. So what you end up getting is this, is you end up getting 1 times that plus $1.60 times that is equal to $1.20 times that. So this is what you end up getting. And then you just go and solve for x. And hopefully you have a handy-dandy calculator. But these numbers end up being pretty decent. Whoops. What's that? Let's get rid of that. I don't even know what that was. It's a crazy day today in the videos. So you get x plus 24. That's 1.6 times 15. Is going to be equal to 1.2x plus whatever 1.2 times 15 is. And again, hopefully you have your calculators. 18 is a very nice, pretty number. And then use all your algebra skills to go and solve for this. So I'm going to go and subtract 24 from both sides. And I'm also going to go and subtract 1.2x from both sides. So I'm doing 2 steps at once, but I think you guys can handle that if you're doing these kinds of questions. So this is 1 minus 1.2. So that gives me a negative 0.2x is going to be equal to a negative 6. So you're just going to go and do that. Again, on your handy-dandy calculator, you're going to divide that negative 6 by negative 0.2, and you get a positive answer. X is 30. Whatever that means. So what does that mean? Because I wanted to know how many pounds of coffee worth $1 must be mixed. So how many pounds would you need? So over here, the amount. It ends up being you would need 30 pounds. Can you imagine having 30 pounds of coffee? Oh, that'd be so much. And I would add it to 15 pounds. Mix it all together, and that's how I would get $1.20 coffee. Now, more importantly is, how much would you sell it for to make a profit? Depends what kind of coffee shop you are, I suppose. So let's turn to one of those chemical solution questions. So maybe you're a scientist and you're all fired up by this one. So if you had an acid solution which was made by mixing 2 gallons of a 90% acid solution and 1 gallon of a 75% acid solution, what's the concentration of the new mixture? And again, we want to be thinking about our buckets. So let's get our science buckets out. And this one, because it has percents and variables and all sorts of things, tends to scare things off. But again, we have the amount and we have the type. So an acid solution, so this thing, it was made up by mixing the following: 2 gallons of the 90% solution. I'm going to be tricky. I'm going to write 90% as a decimal. Also, it had 1 gallon of 75% solution. And I want to know, what's the concentration of the new mixture? I want to know, what's this? Now, how much is the new mixture? If I mix 2 gallons in 1 gallon, how many gallons do I have? 3. So let's go and make our equation. So we have 2 times 0.9 plus 1 times 0.75 is equal to 3 times x. Well, that's not too bad. 2 times 0.9 is 1.8. This, of course, is 0.75, and good old 3 times x is just going to be 3x. If I add these things up, I get 2.55, and that's going to be equal to 3x.
I'm going to divide both sides by 3. Squeeze that in there. Oh. And x is equal to 0.85. So I want to find the concentration of the new mixture. What's the concentration? Is it 0.85? Well, they want to have it in science format, so they want an 85% concentration. So there you have it. How to solve mixture problems, work problems, and some of those problems that maybe seem a little bit tricky, hopefully, are simplified for you.
All right, thanks for checking this out. Hopefully you had a really good ride. And if not, go find your own roller coaster. Till next time.